Oh, as well. Apparently not. Okay, those are the two bell ringer answers. Do you have out your nifty exponent book? We only have one tab left. I'm going to be kind and not check your ones from last night. Mostly because I want you to be able to move on to your menu quickly, although I would love to hear someone's answer. I would love to hear your answer to the homework problems from last night. Surely you did your homework. Definitely. Yes, dear. C to the 68, and you did 4 times 17 to get 68? Perfect. I would love to hear, oh, please tell me what you got.
Okay, so I got D to the negative 45, so that's the bottom punishment.
Okay.
And I got D and 1 over 45. I mean, 1 over D.
1 over D to the 45th. Okay, that's what you meant. That's what you said, right? Oh, yeah. Of course, that's what you said. Definitely what you said. I was a little nervous when Josh started talking and he said D to the negative 45. You know, I would have been mad if he had left his answer like that. If you're trying to get an A in this class right now, the exponent rules, I know it's silly, I agree, but we cannot have negative exponents in our final answers. Okay, just for fun. Gavin hung his head down like, no, not for fun. Just for fun, what is the answer to this? No.
1.
Okay. As long as we've got this straight, I don't care how complicated the thing is. If they raise it to the 0 power, the answer is 1. That is the major secret we discussed yesterday. Okay, so we've got 1 tab left. So far we've done multiplying, where you add the exponents, dividing, where you subtract the exponent, and then a power to a power, where you multiply the exponents, and we worked some yesterday where you could do a power to a power to a power. That was the third example. And you end up multiplying them all. It's great. So we only have 1 tab left. That is the good news. The bad news is, you know, they tend to put the best for last in life.
Is that true?
No, the last one's fine. Okay, so the last one, someone asked me something about it yesterday. You were wanting me to work a problem like this, and I was like, no, we're going to say this. Yeah, it's called distributing a power to a product. Now that is the fancy term we're going to say. I'm just mostly going to say distribute. Distributing a power to a product. And before we go any further, remind me, what is a base?
The big number exponent. Or not exponent, variable.
Okay. And then what is an exponent? What's another word for an exponent?
Power.
Okay. Just making sure we're all on the same page. So yesterday we worked problems that looked like x to the 3rd raised to the 4th. But what if today we had 3x to the 3rd y squared raised to the 4th? Then what happens? What happens when we start having things like this? It starts to get a little hairier.
Right?
It starts to get a little hairier. So when it says distributing a power to a product, I think that kind of implies what we're going to do. We're going to make sure 3 gets raised to the 4th, x to the 3rd gets raised to the 4th, and y squared gets raised to the 4th. Everyone is going to get raised to the 4th power. Everyone. So what is 3 to the 4th power? Does anyone know that?
81?
Yes, it is. Could you just type in your calculator 3 raised to the 4th? Of course.
Yeah.
Or could you just do 3 times 3 times 3 times 3 and figure it out? Yeah, that too.
Would you add
What do we do when we raise a power to an exponent? We multiply the exponent. So it's x to the, and then y to the
8.
Okay, so again, when we distribute a power to a product, what that means is if we have a big long term like this, and it's raised to an exponent, then it's like when Oprah gave everybody a car, everybody gets the exponent. 3 gets the raised to the 4th, x cubed gets raised to the 4th, y squared gets raised to the 4th, everybody gets raised to the 4th. Everybody. Are there any questions about this?
No.
Okay. There was some secret I was going to tell you. There was a secret. Oh, yes. I do have one more secret I want to add before we go to 2 examples of this. It is a secret that we could potentially get in trouble with. Lord knows how we love the negatives. We have a love-hate with the negatives. Okay. Our last and final secret, our fourth secret. And it's another one you probably know. There is a difference between -3 squared in parentheses and -3 squared.
It doesn't like raise the whole thing.
Okay, so let's just write it down for a second. There is a difference between these two. Okay, so Natalia's already getting on it. We had this thing called PEMDAS. It's what you follow when you did order of operations. The P in PEMDAS was parentheses. And it changes things. The E was exponents. So what am I supposed to do first in this top one? You do, and you get +9. Agreed. What do I do in the second one? Do I do -3 times -3 and still get negative?
3 times 3.
Yes, because it's PEMDAS. It said parentheses. That one had parentheses. That's why we did that operation first. But this one, there's no parentheses. So the next order operation on the list is the E for exponent. So we've got to do the exponent part first. So we're going to do 3 squared, which is 9. So it's -9. There is a difference. So if you're wanting a little key to yourself, I would say when it is not in parentheses, the answer is negative. And just for fun, kicks and giggles, another example, -2 to the third would be a negative, well, that's not true. I don't want to do 2 to the third. -2 squared would be -4. Just be wary of your negatives. Be very wary about negatives. They always tend to get us in trouble in life. Oh. Okay, so let's go finish our examples. Oh. We wrote on the flap, distributing a power to a product. So now we need to write on the inside flap what exactly that means. So in this case, seriously, my words are going to be distribute to everything. Distribute to everything. Okay, I'm going to do 3 examples. I have room on my homework flap, so I'm going to do one of my examples on the homework flap. The first example I want to do is for x to the 6th, y to the 7th squared. I want to know what that would be. That's an ugly tooth.
Why is it starred?
I just wanted to put a star today. I felt like being fancy. Can someone help me get the answer to this problem?
16 x to the 12 y to the
Natalia did 4 squared, which is 16. X to the 6th squared, so she multiplied the exponent. 6 times 2 is 12. Y to the 7th squared, she multiplied the exponent. 7 times 2 is 14. Very good. Very good. So good, Natalia. Don't answer the next one. 5 e to the 3rd, f to the 7th, raised to the 6th. I need to know what that would be, and someone's going to have to ask the calculator, because if you think I know 5 to the 6th, I do not. I'm ready for it. Tell me the big number.
15,600.
Agreed. And then, what else? E to the what? That's fine. That makes sense. And then F to the... Okay, F to the 42. That's an ugly 4 in my case, too. So it's 15625. E to the 18, F to the 42. My 4 is ugly, but it is 4 nonetheless. 3 times 6 is 18. 7 times 6 is 42. You asked your calculator for 5 to the 6th because I don't even know that one off the top of my head. I only know up to 5 to the 3rd. Okay, and then the last one. Let's make it a doozy. Let's do... Yeah, so you can put it at the bottom over here. I don't care where you put it. We're done with our booklet anyway, so it's yours now. I'm going to call this a doozy because I would be the most impressed if you didn't ask your calculator what 2 to the 5th is. Oh, yeah, you asked it anyway. So if you asked your calculator, don't tell me.
32.
You just know that?
Yeah.
Me too. 2 to the 5th is 32. He is correct. What else do I put?
50.
X to the 50, Y to the...
32.
Okay, and Z to the...
15.
Okay. So this last rule looked like it was going to be the hardest, and yet after what we did yesterday, it's really no big deal. Just make sure everybody gets raised to whatever the exponent is. It's like when Oprah gave everybody a car. Everybody gets raised to that exponent. Okay, are there any questions about this? Then you are done with your book.